Hello and welcome back. In this video we'll go through a little bit of work in StatCrunch to make sure that we can calculate values to do with binomial distributions. So if you go to the StatCrunch tab in MyLab, we can visit the StatCrunch website, and this will take us here, and I will just open StatCrunch. You may have to log in when doing that. The login is the same as the login for MyStatLab, so everything is on the same account. So if we want to calculate some values with binomial distributions, one quick and very easy way of doing this is we can come to stats, and we can come to calculators, and we can go to the binomial calculator. And this brings up this screen, and this is fairly easy to use. Here we tell it what n is, which is the number of trials in our binomial distribution. We tell it p, which is the probability of a success in any one trial, and then we tell it exactly which probability we want to calculate. So let's say that we're going to flip 100 coins, and the probability of a success, which I'll call which will be heads in this instance, is going to be 0.5. And I want to know, what's the probability of flipping exactly 50 heads? So the probability of flipping exactly 50 heads out of 100 times is going to be 0.07958, and so on and so forth. So about 8% of the time you would expect to flip exactly 50 heads. We could look at the probability of flipping at least, so greater than or equal to 60 heads. And we'll see that at about 2.8% of the time, we will flip 60 heads or more. So that's pretty unlikely. So 60 or more heads would be considered a statistically significant event, and that would be considered unusual. Let's look, and then you can see the actual distribution itself looks like a normal distribution. And it turns out that the more times we flip a coin, the more like a normal distribution it will look. So let's go back to one of the examples in the previous video, where we shot 10 free throws at a probability of making a free throw at 0.9, and then we can look at the probability of making exactly 9 free throws will be 0.387. So about 39% of the time we would make exactly 9 free throws. We could look at the probability of getting greater than or equal to 9, which will be at 73.6%. So the probability of making 9 or 10 free throws is pretty good. But if we look at the probability of making less than or equal to, let's say, 6 free throws, we can see that that probability is going to be way down to about 1%. So this is going to be a statistically significant event. If we make 90% of free throws on average, making 6 out of 10 free throws or fewer is very, very unlikely. And this is just a very quick calculator for these things. This essentially just implements the formula that we saw, and that formula can easily be typed into Google or realistically any other calculator to come up with those numbers. And this is just one quick way of doing this. And you can access this through the StatCrunch tab in MyStatLab fairly easily.